Hi everybody. Here are a couple more examples working with the arc lengths and the sector areas. I'm going to work through a few of them with you here in this video. I'm also going to attach this worksheet so that you can try some of these on your own. It's not a required worksheet, but I would encourage you to look at the video and try some of these as we're going here. So remember that the idea with arc length, and I'm going to write the formula up here, is that to find arc length, we took the circumference, which is 2 pi r, 2 pi times the radius, or pi times the diameter. And I include that because I do see a couple problems where the diameter is given. That'll make it a little bit easier. Times the arc measure in degrees over 360, and it's that ratio. Okay, or that proportion. Ratio, sorry. So when I'm looking down here, I see this diameter. I don't need to cut that in half to find the radius if I'm just going to double it again up here. So I'm just going to go with this pi times the diameter. The big thing is I need to know for arc AB right here, okay, where I'm looking at. I can even color code that a little bit for you here. So that it maybe shows up a little clearer. So I'm looking at this arc that I'm kind of highlighting right there. Maybe it didn't show up as well as I'd like. Anyway, it's based on the central angle, which here is a right angle is 90 degrees. Hopefully, when you see the pattern here, you realize that filling in here is relatively simple. So the circumference of the circle, I'm going to again go with pi times diameter. Pi times 24 times then the arc measure divided by 360. Well, the arc measure is the 90 degrees out of 360 degrees. Now, it's going to say round to the nearest tenth. That's fine. Round to the nearest hundredth. That's fine. Really, we do want to get a decimal, though. So in my calculator, I'm going to go with 3.14 for pi times 24 times 90 divided by 360. And I know it's a little hard to see in the light there, but okay, you can get that filled in. 18.84. Since I don't have to round anything, I am just going to say 18.84. Down here, I am going to include my unit, just inches. I really want you to see that pattern. So we'll slide over here. We're going to look at arc CE. That's this arc right here. Okay. Now I'm given the radius of the circle at 9 centimeters, so I'm going to use this formula for my circumference. But it's the same pattern. Circumference times the portion of the circle. So now I'm going to have 2 times pi times 9 times that portion of the circle, which again is based on that central angle, which is the 40 degrees. I will make that into a better fraction, 40 out of 360. That is the portion of the circle that the arc is, so we're going to have it be the same portion as the circumference. So 2 times 3.14 times 9 times 40 divided by 360 all at once. Sorry, you can't see all that because it's off the screen. Gets me 6.28. And again, because I'm using 3.4 and I don't have to round, I can leave it right at 6.28 centimeters. And one more example here, and I do want to note that you need to be careful. You're being asked in this question for arc AB, which is this arc right here, not the one that's labeled. So I do need to be careful. 180 minus 60 is 120. I know that that's 180 because that's a straight line as a diameter, so I subtracted the 60. to get the 120 there. Okay. That's really the twist in this problem. Otherwise, okay, same formula. I'm given a diameter, so I use my diameter. Pi times 5 times, now I'm looking here at that 120 out of 360. So I'm going a third of the way around the circle, so I'm going to use a third of the circumference. So 3.14 times 5 times 120 divided by 360. I'm going to get a decimal. Notice it's a repeating decimal, so that 5.23 repeating. I'll round that off to 5.23. 5.23 meters. If I wanted to, I could find that 60. All I'd have to do is change that 120 into a 60. That's the only thing that would change, and I'd be looking at the same problem. Okay? So that's arc length. Pause this video, take some time, try some of the practice problems with the arc length that you need to do. Try some of the other problems on this worksheet. There are some practice down below here if you want to. Okay? But take a moment, pause, catch your breath. When you come back from your pause, okay, you'll be on this side, and we're going to look at shaded sectors here. And so I'm going to come up here, and I'm going to write my sector area formula. You don't have to memorize these. Here, I do need the radius. Pi. I don't like that. I'm going to do the real pi, the squiggle on top. Pi r squared times the arc measure over 360 degrees. Okay, very similar pattern, I said that backwards, to what's on front, but different formula here because we're looking at area now, space taken up by an object, as opposed to circumference, which was distance around. But that's the only thing that's going to change. Really, the structure of this problem stays remarkably similar. Okay? When I'm looking at the shaded section, I have a radius of 6 centimeters, and that arc length is 120 degrees. It's labeled for me right there. So pi times 6 squared times 120 over 360. Same pattern as we saw before, different formula. And now I'm going to do the 6 squared in my head and just do 3.14 times 36 times 120 over 360. You don't have to do that in your head. I just did because I think that's a little bit easier typing it in my calculator. Gives me 37.68, and the biggest difference is that the unit changes from just centimeters to square centimeters, area being a different unit than length. Okay. We can continue these. Okay, I have a radius, I have an arc measure, that's all I need for this. Pi times 8 squared times 45 degrees over 360. And if I'm moving too fast, pause it, write this down, take those notes, slow yourself down, and come back to it. 3.14 times 8 squared times 45 over 360 is going to get me 25.12 square inches. That's going to be maybe roughly the size of a, well, that'd be a big frisbee. I don't know, pizza pan, something like that. Who knows? Last one here. Again, we have a radius, we have an arc measure, filling into this formula. Pi times 12 squared times 60 out of 360. Again, it's that portion of the circle that we are focused on. So get that all into my calculator. And I get 75.36 down here. And that's feet squared, square feet. Now, a 12-foot circle, That's a big tube, maybe something that you're running under a bridge or something like that. I don't know. But that would take up a lot of space there, having 12 feet of circle. Again, pause this, come down here, try some of these practice problems, try some of the other homework problems. Okay, don't just watch this video straight through and then try to do this all on your own. Come back to the parts that you're not sure about. Join me in the office hours to ask questions. Okay, but hopefully that helps, and we'll see you in a little bit.